Hello, hello. I see 6 people watching. If you're listening, can you type one in chat? Type one in chat if you can hear me. All right. Okay, I see one. Nice, nice. All right, so we're gonna start the stream soon. I think maybe more people are joining. Hello, hello. How's it going? Well, we'll let other people join as well. Let me introduce myself. Hello, everyone, and welcome to the second part of our workshop series. We will be talking about zkLogin and some of the features related to that today. I remember last time Harrison talked something fun about himself. So maybe we'll have some interactive session for the next slides. So how many of you guys have Googled this question? And trust me, this is also a question I asked as well when I first started doing programming, which was how do you exit Vim? This is, I think, one of the most popular question on Stack Overflow. So if you have asked for this question, type one in chat. It's a classic one. Type one in chat if you have also Googled this. I don't see one. Apparently, I guess you guys are very good at Vim. Anyways, just a quick announcement before we jump into the workshop. Sui Basecamp is going to be held on April 10th at Paris. So if you are around, consider joining the Basecamp and meet us in person offline. Second thing is that Sui Overflow will be starting on April 21st this year. So I would like you guys to consider signing up and get notified when the hackathon actually starts. And the prize money for this hackathon is going to be, I believe, 500,000. So quite a sizable pool there. So if you're interested in that, consider signing up. I'll provide the link later at the end of the stream as well. I see that we have 15 people watching now. So with that being said, let's see what are some of the nationalities of everyone joining today. I think we have a very diverse group of people, just from people signing up. Thanks again, everyone, for signing up and filling out the questionnaire there. We have people coming from all over the world and also from a wide variety of background. And I think everyone will be seeing things from a different perspective from today's workshop, and hopefully you'll learn more about zkLogin than you came in. And with that being said, let's introduce today's speaker, Joy. Joy is an engineer at Medicine Labs working on zkLogin related features. So let's give her a welcome and have her on the stage.
Hi everyone, my name is Joy. I'm really excited to be here and share more about how zkLogin works. And I want to start off by kind of talking through the bigger pictures of how it works. And I also, most importantly, want to show you guys how to dive in code and start integrating it from today. So I'm going to present my screen. Cool. So a bit of agenda today. So I first wanted to kind of talk about like the Web 2 versus Web 3 onboarding for those of you not really familiar or kind of wanted to, see the difference between these two. And then the next step is to kind of really go over how zkLogin work on a big picture and how do we kind of uh, develop this idea in different stages and really help you fundamentally understand what's the mechanism behind it. And then I wanted to kind of cover a React app in a demo, and then show you guys, if you wanted to add zkLogin to your uh, dApp that built on Sui today, how do you do it? And then the end, I want to talk about like some of the considerations of developers and people who are integrating with this, some of the practical concerns and solutions. Um, and lastly, I wanted to talk about some of the extensions of zkLogin. In particular, we're going to launch on mainnet with Multisig and zkLogin, meaning that you can create multiple, maybe say your mom's Google account, your dad's Google account, and they can also with your Google account, and then three of them can become a multisig that can, say, sign transactions. Cool. So let's get started. So what is Web3 login? Um, at the foundational level of what a Web3 login is how when you interact with a blockchain, you always need submit transactions. And how it works is that you as a user, you will have a private key. And for a lot of you guys are familiar, that's the 12 words that you generate and should never let anyone else know when you're creating a wallet. So that's considered a private key. And a private key can produce a signature. The signature itself doesn't say anything about your private key. And essentially, when you submit to the blockchain, you're essentially submitting the blockchain a signature and a public key. And how does this work is that for anyone who can see a signature and the public key and this transaction that you're submitting, blockchain can provably verify that you are in possession of this private key. So this is some sort of asymmetric cryptography, and it's sort of magical in the way that you never need to share your private key, but then the fact that you produce the signature can verify that you are the ownership of a private key. So this is probably something you guys are familiar with Web3 Wallet, and the shortcoming is very clear here that you need to really make sure that you never lose this private key. You need to write it down. You need to do backup, and losing it meaning it's game over and you're never going to recover it again. And on the other hand, you also probably interact with a lot of the website these days with a Web2 login. What it usually look like is something on the left here. When you're logging into, say, Grafana Cloud, which is an application, they usually provide you this option of some providers. And what usually happens is like, as a user, you may already have a Google account or a GitHub account or Microsoft or Amazon. So, oh, you don't actually need to create a new password and then save it anywhere. You can just click the button and then eventually being able to authorize to use the application with your existing credentials with Google. So zkLogin essentially kind of focusing on this idea of like login. How do we kind of benefit from this Web2 UI where you already have a credential with someone and you don't really need to remember it or guard your private key with everything, and then losing it will mean losing your asset. So essentially, we wanted to leverage this OAuth login flow so that we can somehow alleviate the burden of managing your private key. But at the same time, we want to still give people this idea of self-custody, meaning that you are the only authorized person to move your asset on chain. So that's kind of the fundamental idea of what is zkLogin trying to do. So let's first take a closer look of how the Web2 login work, and then by looking at it closer, we can probably see some of the hints how we designed zkLogin. So when a user wanted to access a website, the website first gave you this URL, and it calls like sign in with Google. It's some widget that you're probably familiar with on the left that says, "Oh, choose account and continue with this like application." And it has like a list of your emails, and then you can click on them. And essentially, the website sends you this URL. And if you look at this URL on top of this screenshot, it essentially unpacks to something that looks like this. This is a URL that is the website can define it by putting in their client ID registered with the Google, and they also gave append a redirect URL saying, "Oh, here's the link, application URL for you to send this token to." So in a Web2 login, you're essentially using this token called the JWT token, in full name JSON Web Token, to authorize with the website. So when you click on sign in with Google, and after you finish this screen, Google actually respond a JWT token to the website that you specify the URL saying, "Hey Google, can you provide some information about this user?" And then also provide a signature such that we know the data actually come from you, and I'm the only website that the user giving consent to on this screen. So to unpack that JWT token a little bit, there essentially what the JWT token is something you see on the left-hand side. It essentially have three parts. The most important part is this payload that kind of contains a lot of information about what does the Google tell the website about you. Some of the highlights here is that it tells you who's the issuer. So for example, in this example, I use Twitch as the provider. Could also be Google or anything that kind of possessive your credential that wanted to tell Google, "Oh, here's somebody with the subject ID, and her name is Joy," and etc. And also, most importantly, this blue part is RSA signature as a signature that the provider signs over this entire payload here. So essentially, you can think of this as some of your personal data and some of the expirations, etc., packaged into something and then signed by the provider, for example, Google, that hands back to the application, say, "Hey, here's some authenticate information," and I provide a signature over it. And there's a very interesting part here called nouns. So nouns is something the application can define in this URL. And whatever you put in the nouns, the Google or the provider will essentially consider taking that as a payload and provide a signature over it. And in a bit, we'll see how we use this nouns field to make zkLogin magic work. So here's a trick on how we actually use this nouns field to implement zkLogin. So essentially, the nouns here in the official OpenID spec, it doesn't really say much about what you can put in here, and essentially, usually applications use it as some sort of incremental sequential number, so to prevent replay attack. So the idea of a zkLogin is that we have this trick of putting the nouns to a public key and expiration. So the trick here is that you're essentially asking Google to give you a certificate over a public key and expiration and provides us their signature over it. So you're essentially kind of having Google to commit to a value. So here, so this is how we kind of registered a key with Google. And the way zkLogin work is that you as a user, you can generate a private key. And the awesome part about this is that you don't need to remember the private key anymore because you can just always give Google to sign over a public key and then return it back to you. So now we kind of get to the very core part of how zkLogin work is that you are using a private key on your local end, and the public key itself is registered with Google. And this private key is an ephemeral private key that you never need to remember. And the next question you may ask is, okay, so now you're telling me the public key is changing every time. How do I define the address? Because traditionally in a blockchain, the address is defined as the hash of a public key. So here, we're no longer using the public key because it's always changing. So what we did is that we look at this JWT token and then look for values that never change. So most importantly, the subject field is a value that is globally unique per provider, per user. So, uh, so for example, me and another person will have a different sub for Google. So this ISS here means the issuer, and the audience here means the application that you're using. So this is an identifier that every application needs to register with Google Cloud to get this client ID that represents your application. So now that we have this sort of a different way of defining a zkLogin address, it's essentially taking the hash of a subject ID, which is unique to you, a issuer, which is unique per issuer, and then audience string, which is unique per application. So we really scope it down, the address, into some value that doesn't change. And we also introduce this idea of a salt. The point of introducing this value is that this is something that we wanted to protect your Web3 identity with your Web2 identity. If you just take a hash of the first three values, you essentially tell Google what your Sui address is. And the provider themselves can figure out what your address is. And because this value never changes, we wanted a way for you to unlink your Web3 credentials with your Web2 credentials. So we introduced this value called salt. We'll get into a little bit deeper of where to store this value and what's the significance of having this salt. But for now, you can think of address as derived out of something that doesn't change, and it has nothing to do with the ephemeral public key we talked about earlier. So you might notice so far, we never talk about the ZK part of zkLogin. As you may know, ZK stands for zero knowledge. And so far, we come up with a solution that there is no zero knowledge. And it already worked in the sense that we have a user here that generates some private key and public key. And it calls Google to register a JWT token that commits to a public key and expiration. Using this private key that the user already have, you can sign a signature over a transaction. You can produce a signature over a transaction. So essentially, with this JWT token and this signature, we can already authorize the blockchain a transaction. And the best part is the user never needs to remember the private key because every time you forget your private key, you just go to Google and register a new one. So this works. So now we have a zkLogin without any zero knowledge, and this is the simplest model of how zkLogin work. So some of you might notice there's some issue with this. As you see earlier, this JWT token actually has a lot of sensitive information about who you are. So for example, my name is Joy, for example, that register with Google, then they can they essentially are part of the GWT token. If I publish this as a signature on chain, everyone can know that, this is my transaction. So this is the problem, that we don't want to actually reveal the entire GWT token with these private information. So a very quick recap of how zero knowledge work is that a zero knowledge proof is a proof system that can take in some private input. These inputs are private, and then the output is the proof, which reveals nothing about your private information. So it's a great way of kind of transferring this transparent token with a lot of private information into this opaque proof, with a bunch of like non-intuitive things in there that essentially hides all these private details on chain. So now we kind of come to the final version of what zkLogin is that you essentially replace this JWT token with a zero knowledge proof that shows that the nonce is indeed set to the public key, but it also has all the sensitive field. And how do you generate a proof? I won't cover it here, but we'll talk about it later around in the developer guide, how to actually, call a prover to generate this proof for you. So just to really quickly to recap what we just said earlier. We first have a user, and we ask the user to log in to a OAuth provider, such as Google, to register a public key. And then the user also keep this private key local on the app frontend. And the private key here will produce an ephemeral signature, and the OAuth provider will return the user a JWT token, and the token itself will go through this proving service to generate a zero knowledge proof showing that you indeed registered a public key. And along with the zk proof and the signature, we submit it to the blockchain, and then you're able to create any transaction with such setup to authorize a transaction on chain. So I'll take a pause here. If there's any questions, please speak up, or I'll take a look at the group chat. Cool. I don't see anything so far, so I'm going to continue, and we'll save some time for questions toward the very end. So the next part, we're going to do a quick demo of how zkLogin work, and I wanted to walk you guys through a React application that essentially shows how things works in code. So the example I'm using here is a demo made by Polymedia. They are contributing to the Sui community, and it's really awesome that they make this demo, and I found their code really clear to follow, so that's what I'm going to be using. So here we can see you can log in with Google or Twitch. I'm going to use Twitch, and you can see that it's requesting a zk proof, and it also gives me a user address. As we talked about earlier, it is using some of the fixated field from the JWT token. And now I'm going to request some Sui to my address on DevNet, and hopefully it works. So now I have 10 Sui in this zkLogin address. Now I'm going to create a transaction, and you can see something happened really fast there. It basically just uses the zk proof locally, and then uses the private key that I have in the front end to send a transaction. So let's take a look at this transaction real quick. We can see 22 seconds ago, that's a transaction it just sent. And if you were to look at the user signature field, It is a zkLogin scheme, and the signature is very long, but you can see it's a very long string that is essentially composed of the zk proof and also the signature produced by the ephemeral public key. Okay, so now we're ready to look at some of the code. So this is the code base of what we just looked at. The demo that we just looked at is in the polymedia-zkLogin demo. So these are some of the CSS stuff. I'm going to skip that, and we're going to jump in right into the app implementation itself. So when you begin a zkLogin, what you essentially in the backend does is that you look at the latest epoch on the Sui blockchain, and then this Sui client is something that you define. For example, it could be DevNet or mainnet or testnet. zkLogin is available in all of them, so you can use any of them to do it. And then you define a max epoch here where that you wanted this ephemeral key to be valid for that long. And then now you can generate an ephemeral key pair by using the EDDSA key pair function here. And then the next step is that you wanted to generate a nonce. As we talked about earlier, the nonce essentially has the public key and the max epoch. And we also wanted to hide to Google that, oh, you're actually, doing a zkLogin. So we added some sort of randomness to really hide this value. So now we have the nonce, and then we can actually save the proof. Save these values locally for a little bit, for however long you want this ephemeral key pair to be valid. And the next step is to really set up this URL parameters that can direct the people to log in. And in this implementation, we already actually implemented how you configure this URL with Google. And as a developer, you will need to set up a developer account with Google. For the sake of time, I won't show that part. But it's documented in our website as well. So once you construct this as URL, essentially has the nonce field that we generated earlier. It also has the redirect URL, which is your application, and make sure that we specify the response type as ID token that would allow Google to return a JWT token to the front end. And the scope here is called OpenID. That's essentially a fixed value that we need to essentially ask Google. That is a type of credentials we're asking for. And now we're ready to ask the user to log in and then redirect back directly into your application. So once you have the application redirected, it's actually in part of the URL redirected in your application. So all you need to do is to grab that token from the URL fragment and to parse this JWT token. And the next step is to actually generate the salt. So in this implementation, we actually use a dummy salt service that will just give you a simple value of what this salt is. We'll cover a little bit later on what other ways to manage this salt. So all the way here, you're just receiving the salt, and then now you have this value. And the next step is to generate a user address. As we mentioned earlier, we actually abstracted away some of the functionalities in the zkLogin TypeScript library, where you just need to give it your JWT token and the user salt to generate the user address. And now that you have this user address, you will need to generate the zk proof. And remember, we already generated the ephemeral key pair from earlier. And remember, we need to use the same key pair's public key. And in our implementation, we offer a mist and run prover service because generating a proof is actually a very expensive operation. that is very slow on the client side. So we made the decision of having a server that can generate the proof under a second, whereas locally it could, on some machines, can take up to 10 minutes. So what the zk proof does is that it will, the prover will take in this payload with all the necessary values and then return a zk proof, which is this opaque representation that shows that you are setting the nouns correctly to the public key, and you also are, having a valid JWT token that is indeed from you. And now that we have the zk proof, that everything from there should be incredibly fast, and you don't need to set up again. And a lot of you guys are probably familiar. All you need to do is to sign the transaction with your ephemeral private key. And remember that this is the same key pair that you registered with Google. So you never, if you refresh that ephemeral key pair, you will need to essentially use the right key pair that is actually corresponding to the proof that you generate with. This part looks really familiar. All you need to do is to use the Sui.js library to sign a transaction, and you get the signature bytes. And not the last but not very least, all you need to do now is to combine the zk proof and the user signature. And there are some intermediary value generated here, but they're all provided by the zkLogin TypeScript library to generate the zkLogin signature by combining all the value. And at the very end, you can execute the transaction with the zkLogin signature, and as we see earlier, the transaction will execute correctly. So I am going to stop right there, and
Yep, there are some questions
for
here.
question.
Yeah.
Cool.
So I'm going to show the first question on screen. How is a zkLogin address consistently the same, considering the salt remains the same?
Yeah, that's a good question.
Yeah.
I'm going to share back my screen. So that's actually a part of the definition of what a JWT token is. So there are some values that are not changing, no matter how many times you authenticated with a certain website. So the subject ID is a value that is always unique to you, and it never changes, even though the application, can refresh some of the expirations, etc. And the issuer here is always fixated to Google or Twitch or whatever provider. And the audience is also not changing as long as you're logging into the same application. And the salt is a value that you as a user either needs to remember, or you use some sort of server backend to remember this for you. But the salt should never change as well. So essentially, you're using all these unchanged value to generate the address, so it should never change.
Now, for the second question would be, is the randomness in line 84 the same as the salt, which is used to generate the address?
No, that's a good question. So the randomness actually, short answer is that it's different and it's only being used once. As you may notice, the randomness is also used as part of the input for the prover. So it is a value that the prover takes into account so that it knows what's generating. It will be essentially encapsulated in the zk proof. But don't confuse it with the salt, because salt is supposed to be a unique value that you should remember. And this randomness value can actually change every time when you register a new ephemeral key.
Okay. And we have another question from Purushottam. We're using Inoki. ZK proofs are stored in session storage. We cannot access it from multiple tabs, hence forcing our users to log in again across multiple tabs. Can you suggest a way to improve the UX?
Yeah, that's a good question. So Inoki is definitely still kind of in development. And yeah, you're right that there's Inoki is SDK. For those of you who don't know, it's a more packaged SDK than the zkLogin SDK. So there's essentially lesser line of code, but in some way it has less things that you can customize on. Um, and I will definitely relay that feedback to the Inoki team on how to make that better and potentially, um, you know, make that experience better.
Okay. Any other questions that we have here? Also, I forgot to present your screen earlier. So
Oh,
first part of the demo was cut off. So maybe you can show that again so people
oh,
can
cool.
see what you were referring to earlier.
Oh, cool. Yeah, I can clear the state. So I'm guessing is this page.
Yes. Yes.
Um,
Mhm.
Yeah, so basically is what we kind of walk through the code. As a user, as a front end, you essentially tell the user about like setting up this URL, and you can tell we talked about this nonce is being set to this value according to the ephemeral private key on your front end. And the moment you click authorize, this page, it went by really quickly, but there was a redirect ID token in the URL that essentially was grabbed by this front end, and they're able to capture that and then create the ZK proof for it. And if you create a transaction, and it should just work, where you can always double check the signature field is indeed zkLogin with a very long blob that contains the zk proof and ephemeral signature. Cool. I guess I'll continue on my slide here. We talked about the code walkthrough and demo, and some folks are probably wondering, what are the security considerations and privacy considerations that zkLogin take into account? So first of all, the GWT token is a token that is only scoped to a specific client ID. What that means is that when you ask Google that you want this payload, um, if a malicious app essentially requests on your behalf, they would not be able to get your GWT token for a specific application. So how that works is like, as a developer, when you're configuring the app, you actually tell exactly where the redirect URL is, and only that front end of that application can receive it. So every ZK login address is actually scoped to a specific application. The design is intentional, as some of you may notice this before, that your ZK login address with one application is different from the other. This is for the exact reason is that we want them to be domain separated, so that compromising one website would not, let you lose your asset across a different application. So zkLogin address is sort of some sub-account of this master credential, and you can have different accounts with different apps. And the second thing I want to cover is this salt. I think some people already asked about it. So what is this value? Is this like another password I need to remember? Is it a private key? And why, it is something persistent and you also need to remember. So we talked about all the different trade-offs in the doc. There are different ways you can manage this. I guess the most privacy conscious way is to have the user to remember this salt, because it is a value. The moment you lose it, you cannot derive your zkLogin address, and it is a somewhat like a secret value, and you always need it to derive your address. But in some way, it is not a private key in the sense that if somebody just took your salt, they have no way of transacting out of your zk address account at all. A good mental model to think of this is like it is a two-factor authentication. You first need a salt, you also need the user to actually go through the OAuth login process to actually get the zero knowledge proof and then use that along with the salt to transact on the zkLogin address. So it's some sort of like a middle ground between a private key and some value you need to store. You can make it public. And another suggestion we made to developers is that you can actually have some sort of salt server hosted by the backend, or you can use the Miston hosted salt server that essentially will deterministically give you the salt based on a JWT token. So every application per user will have a unique salt value so that there's no one's address will be the same. Cool. I will, the last but not very least, I wanted to cover the multisig and zkLogin demo. This is something very new that we just finished implementing in DevNet, and we're going to mainnet in the hopefully next 2 weeks. So I'm going to walk through the demo, and I'll encourage all of you to look at the code if you want to. You can see the application is actually forked off the demo that we just saw earlier from Polymedia. So you can always, you can refer to some of the common element here and be able to use it. So this is also in DevNet, and what this app does is essentially creating a multisig address based on any combination of number of providers or private keys. And then you can define a threshold of how many people, how many waits do you need to authorize a transaction. And for the demo purpose, each provider is fixated with a weight equals to 1. So I'm going to do a demo with Twitch as well. So now I have this page again. As you see, there's announce, redirect URL, etc. And I click authorize, and it will request a zk proof. It will take a few seconds, and you can see that there is a public identifier for Twitch being recorded here, and then at the same time you can add a private key. For demo purpose, this is just something I store in the session storage a value. And the next step we do is that we can define a threshold. And for the purpose here, we can have, let's say, 2. And I click to multisig address. So now I actually have an address defined based on 2 public identifier with a threshold 2. Using the faucet, let's see if this works. Sometimes you get rate limited. If it doesn't work, I'm going to use the DevNet faucet. Cool. So I will now have that 10 balance here, and I'll create a transaction. And now this is just a dummy transaction, there's nothing in it. What I do is I click sign transaction. This essentially creates a zkLogin signature, and you can see it's pretty long. And now you can also sign it with the private key, and it also produces a signature is a lot shorter than the zkLogin signature. And then now I click submit transaction. And what it does is actually combine the signatures into one multisig, and then eventually publish this to the blockchain. And for a quick demo, for a quick look here, the transaction succeeded, and you can see there are 2 signatures. One is a zkLogin signature, and the other one is the ED25519 signature. So that is a multisig with zkLogin. And feel free to look at the code later. It's very similar to the single sig multisig application, so probably pretty easy to follow along by yourself. I'll pause there and let me know if there's any more questions around this.
Yes, we do have one question, which was, do we have any alternatives to redirect logging?
I'm guessing you're referring to the flow where the application frontend received the JWT token from the login. Um, Feel free to follow up there, but I'll answer what I think the question is. There are other ways that you can receive the JWT token. Um, if you look at the OpenID spec, there's this a different flow where um, when you log in, the front end will receive access code, and you need to make a post request to the to say the provider themselves to receive the JWT token. So it is up to you how you want the front end to receive it. Um, and in fact, some applications will, some providers, I think, um, Slack or Apple, they actually forces you to use a different way to get that JWT token. So yeah, so that's something front-end related, and you can do that. All you need the JWT token is to have that value to generate the proof, and also to use that to retrieve, to derive your salt, essentially.
Any other questions we have here?
Cool. It sounds like you guys have a really good handle on how it works, and we definitely try to make this integration experience very smooth and easy. If you're working on the hackathon and thinking about adding zkLogin to it, it's almost the answer is you definitely should, because it's not a lot of lines of code, and we actually already showed you how to implement it. And if you're using React app, you can just use some of the code there. And if not, we have the zkLogin TypeScript SDK, and eventually the Inoki SDK to make this experience very seamless. Oh, I see a question. Is this idea open source or has a patent? Can anyone adopt this logic anywhere? That's a good question. So we open source the SDK and obviously all the code in Sui. So in terms of verification, they're open sourced. And we didn't publish the zero knowledge circuit code, although we did have it like audited. If there's ways you wanted to use it in other blockchains, I think it's technically possible to use in other blockchain as well. It is idea that we also leverage some of the core ideas from OpenPubKey, for example, to how to use this nouns field to implement this.
We have another question. Can I use passkey as one providers for multisig?
Yeah, that's a good question. That's actually part of our roadmap. It's currently passkey is not supported in Sui yet, but we are actually scoping a design and hopefully having that as part of the native authenticators in Sui. What that means is that you can use the passkey by itself, and you can also use it as part of the multisig, and you can even compose it with a zkLogin or a single signature or anything you want inside a multisig.
Another question. Is there a way we can use zkSend without having to go to zkSend's website so that the Sui coin remains within the zk wallet created in our app?
Is there a way? I think I'm not too familiar what that means to use zkSend without having to go to zkSend's site. I think you can. Oh, so to answer the second part, it says the coins will remain within the zk wallet created in the app. It is correct, as I mentioned earlier, every zkLogin address is scoped to this application specifically. So you do need some way to, you need some ways to, transfer it out. I'm not familiar with the zkSend SDK that requires you to go to the site, but if you ask a question in Discord, I think someone from that team is able to help.
Another question, for further questions related to this, do we have a communication channel? I think maybe I can answer that. I think the best way to reach us would be to join our Discord or to use the forum here. Where was the thing here? Let me show you. So you can use the forum here. You can also join the Discord. I'm going to post the Discord link soon in the chat. I hope that answered the question there. I think we have another question. When will the passkey be supported? This is a killer function together with zkLogin.
Yeah, I totally agree. I think having ability to, use this passkey as like from the hardware guarantee and also have zkLogin where, you're able to use a ephemeral key and, not having needing to store a private key is very good functionality. We are scoping it now. I'm hoping like next quarter we'll definitely start working on it and being able to make it happen on Sui.
So I'm going to also post the link to our Discord channel. You can see it here. Okay. Any other questions? Thank you, Praveen, for answering that, for asking the question. Okay. I think we can go to the next section of the workshop. Just a reminder that the next episode of the workshop series will be on April 3rd. For those of you in different time zones, I think for people in the US, it's going to be on Tuesday. So I think if you subscribe to some of the notifications, you'll also get this notice. It's going to be on-chain randomness, which is also a track for the Overflow Hackathon. You can sign up using the link go.sui.io/flow3. I'm also going to type it out so you guys can like have it later. Flow3. So that's the link there. And also, we would like to have some feedback. It will greatly help improve our workshop series going forward, as well as to Joy and I on like how we can improve in the future regarding the presentation. So I think, let's see, where it was. Yeah, let me also type out this one. So Let's see. Is anyone providing the feedback already? Let's see. Let's see, 15 of you guys here. All right, if we can get like, 3 people doing this, we're gonna demo the zk send. If we get 3 responses. So I'll just also share the screen here so you can see what the survey actually looks like, right? It's gonna be basically 2-pager, one asking with basically 5 questions asking about a little bit about yourself. You don't need to put name or email down if you don't want to. The next page is gonna be actually about how we did in the presentation. I think people are also dropping off, but I'm gonna wait here a little bit. But that's pretty much all we have for you today. Just also maybe a reminder here that, let's see if I can present again, that if you haven't signed up for Sui Overflow, please go to sui.io/overflow to sign up for the oncoming hackathon. This is going to be happening on April 21st. Also for Basecamp, if you can attend it, if you want to meet us in person, you can go to sui.io/Basecamp. That's pretty much it. Thank you everyone for joining. If you can, please also provide us some feedback.
Thanks everyone for listening.
Yep. Thank you everyone. I'll catch you guys next time.